circular coil of 30 turns and radius 8 centimeter, 8 into 10 is to power minus 2 meter, carrying a current of 6 ampere, carries a current of 6 ampere and is suspended vertically in a uniform magnetic field of magnitude 1 Tesla. The field lines make an angle of 60 degrees with the normal of the coil. Angle of 60 degrees with the normal of the coil. Calculate the magnitude of the counter torque that must be applied to prevent the coil from turning. Same question, torque कितना act होगा ये calculate करना है. BINA sin alpha. Important point, फॉर्मूला BINA cos थीटा और BINA sin alpha. अगर हमें कॉइल का फील्ड के साथ एंगल दे रखा है तो कॉस की टर्म्स में फॉर्मूला होगा, और अगर हमें एंगल वी आर गिवन बिटवीन नॉर्मल टू द प्लेन ऑफ द कॉइल एंड द मैग्नेटिक फील्ड तो फिर साइन की टर्म्स में एंगल होगा. बी 1 टेस्ला, करंट 6 एम्पियर, नंबर ऑफ टर्न्स 30, एरिया पाई आर स्क्वायर into sin 60. सॉल्व करेंगे इसको, the value comes out to be 3.1 Newton meter. This is the torque acting on the coil due to the magnetic field. This is the torque acting on the coil due to the magnetic field. We need to apply an equal counter torque. We need to apply an equal counter torque to prevent the coil from turning. ठीक है, that's first part, answer for the first part. Second part is, would your answer change if circular coil is replaced by a planar coil of some irregular shape that encloses the same area. Area अगर same है, radius से हमने area calculate कर लिया. Now we have, earlier it was a circular coil, now we have a coil of any irregular shape, has same number of turns, but the area is still the same, the arrangement is still the same, the orientation of the coil is still the same, सब कुछ सेम है, सिर्फ शेप चेंज कर दी गई है और कोई irregular shape है. तो will there be any change in the answer? Not at all, सब वही का वही है, तो टॉर्क भी उतना का उतना ही.